So you had an idea about using tides to measure astrodynamics. Can you tell me about it?
Exactly. Yeah, okay. So I had this idea of why do we have high tide, low tides at all? And so to first approximation, it's you have the moon and then you have the earth and the moon. And as the moon goes around the earth, it drags the water in not like around the earth, but in terms of amplitude. It makes high tides and low tides. So if we could see how the high tides and low tides are moving, we could say, well, the cause of that is from the moon. Now, it's hard to measure stuff on the moon, but we can measure the high tides very easily. And so if we see that there's weird patterns in the high tide, low tides, then we could make some statement about what's going on in the moon.
Okay. I mean, okay, so you could make some measurements about what's going on the moon, but could you get anything else? Like, is there like a hidden Jupiter signal in the tides?
There is. I think that's exactly what we see here. So if it was just the moon and the earth system causing the high tides and low tides, we would see the high tides be consistently the same height. What I think this signal is saying here is that there's three main gravitational forces for the high tides and low tides. There's the moon, the
Hmm.
earth, the
Sure.
sun.
Okay.
So I think that's when you get these super high tides, when you have the moon, the earth and the moon. So the moon's pulling the water towards the moon. And then also if these happen to be aligned up with the sun, you get a super high tide. All three, all two gravitational forces pulling in the same direction. And so then I guess for completeness, the opposite of this is if the sun and the moon are in opposite directions, that's when you get these moderate high tides, these little high tides. Yeah, I
Yeah.
think so.